Happy Tuesday. How's it going, Venus?
What's that, Ms. Baldwin?
Success. How's it going?
Good.
Good. Looks like it's you and me. I don't know where the rest of your class is. Let's go and get started on the do now. So what was your favorite thing you did this weekend? Go and write your answer in your in the chat. And then the two share out loud questions are how does the H value move a graph and how does the K value move a graph? And then you'll also need a graphing calculator for today's lesson.
I don't know what I do with my graphing calculator.
What happened, you said?
I said I don't know what I don't know what I do with my graphing calculator.
Okay.
It's somewhere around here.
Okay. All right, for those of you that entered, Nancy and Liana, make sure to turn on your video. Here's your do now. All right, one more minute. Make sure you take out your notes from Friday so that you can answer number 2 and number 3. And then also take out your graphing calculator if you don't have it out yet. All right, how does the H value move a graph? How does the H value move a graph? What do you have for me, Nancy? Nancy, do you have an answer for number 2?
Yes, it has to move either like side, like either that like to the left or to the right.
Yes, and then how do you know if it moves left or right?
What was the question? What?
How do you know if it moves left or right?
If it's positive or if it's negative.
Yeah, so positive means you're going to the
Left, and then negative means you're going to the right.
And then how does the K value move a graph? How does the K value move a graph? What do you think, Sandra?
I guess up and down, and when, yeah, up and down.
Up and down. So if it's positive, it moves it
Up, and if it's negative, it moves down.
good. Awesome. All right, let's go ahead and do our good things. So today's good things are going to come from Venus, Ethan, and Liana. So Venus, go ahead. What's your good thing?
have dance today.
Oh, awesome. Exciting. What type of dance do you do?
Major.
Very cool. Thanks for sharing. Ethan, what's your good thing?
That I'm going to take my test to get my learner's permit after school today.
Woohoo, exciting. Awesome. Thanks for sharing. And then Liana, what's your good thing?
A good thing is I got a new job.
Ooh, where'd you get your job?
Well, it's the same job, but I got transferred to a closer location. It's at McAllister's.
Oh, awesome. Very cool. Thanks for sharing. My good thing is that the weather is nice today, and I'm going to go play tennis. So I'm excited to be outside and enjoy the weather. All right, let's go ahead and get started with our notes for today. So actually, before we do that, are there any questions about the homework from Friday that I can go over? Okay, let's go ahead and go over our notes then. So graphing radical functions, we're continuing that today, but we're gonna add another component into it, and we're gonna use our graphing calculators to help us graph. So if you have those, please take them out because we will be using them. So on Friday, we talked about translations, which is just shifting a graph to the right and to the left. A transformation, on the other hand, changes the size, the shape, or the orientation of the graph. A reflection will reflect or flip a graph over the x-axis. A vertical stretch stretches the graph away from the x-axis, so it makes it long and skinny. And then a vertical shrink will shrink it down towards the x-axis, so it's going to be kind of fat. And that is all the types of transformations we'll be talking about today. All right, we're going to do a quick review of what we did on Friday. So remember on Friday we talked about the square root function and the cubed root function. The square root function has an index of 2. The cubed root function has a cubed root of an index of 3, excuse me. And then remember we came up with a table of values for the square root function. So we've got 0, 0, 1, 1, 4, 2, and 9, 3. So if we graph that, we've got 0, 0, 1, 1, 4, 2, and 9, 3. That was just a review from Friday. And then for the cubed root function, we've got -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So we've got -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Any questions about that? All right, then we have the transformation. So there's 3 variables. There's the h, the k, and the a. On Friday, we focused on the h, which is underneath the radical, and that's the horizontal shift, like Nancy said. If it's a plus, it shifts it to the left. If it's a minus, it shifts it to the right. The k is the number outside of the radical, so behind the radical, and it's the vertical shift like Sandra said. So if it's a plus, it shifts it up. If it's a minus, it shifts it down. Questions so far? All right, the last one is a critical point. We didn't really talk about this on Friday, but I introduced the idea. Your critical point is going to be helpful for your table of values today. And the way you find your critical point is just, it's the point h comma k, where h is the opposite side. So whatever your h is, just take the opposite sign, k stays the same. We haven't talked about a yet. So a represents two different things. It's always going to be in front of your radical. You'll always find it in front of the radical. The first thing it will tell you is if there's a vertical stretch or a vertical shrink. So you just look at the number, forget about whether it's a negative or a positive, just look at the number itself. If the number is bigger than 1, it represents a vertical stretch. If the number is less than 1, it represents a vertical shrink. So again, don't pay attention to whether it's positive or negative. Just look at the number. If it's bigger than 1, it's a stretch. If it's less than 1, it's a shrink. If you don't see a number, then you can assume the A value is 1 and it's going to be neither a stretch nor a shrink. So you only worry about stretches and shrinks if it's a number other than 1. The other thing you want to be concerned about, because the other thing that the A value will tell you is if there's a reflection. So if A is negative, the graph reflects over the x-axis. If A is negative, the graph reflects over the x-axis. Does anyone need more time to copy it down before I flip the page? Okay, let's go ahead and get started on examples. I've been talking for too long. So the first example, graph the following function, f of x equals negative square root of x minus 1. And we're going to go ahead and first identify the type of graph. So do I have a square root function or do I have a cubed root function? What do you think, Venus?
You got a square root.
Good. I'm going to leave the domain and range for now, and I'm going to identify my A value, my H value, and my K value. I'll start us off with the A value because we haven't talked about that before. The A value is the number in front of your radical. So right now you know there's a negative, and there is no number, so you can assume that it's a 1. So negative 1 is your A value. I'm going to go ahead and call on someone to give me my H and K. So what's my H and what's my K from this problem? What do you think, Nancy?
Your H is x, which is just 1, and then negative 1 is your K.
So remember, your H is actually going to be negative 1 because your H is the number underneath the radical. And then Nancy, do you have a number behind the radical?
No.
No, so that means you don't have a K value, so your K value is 0. Does that make sense?
Mm-hmm.
All right, so when we talk about how this affects our graph, the A value, if it's a negative, it means that it's reflecting over the x-axis. And then we forget about the positive and negative and we just look at the number. So the number is just 1, so I don't care about it in terms of stretching and shrinking. The only time you want to care about stretch and shrink is if this number for A is something other than 1. This minus 1 for the H means I'm going to the right 1. And my K value is 0, so I'm not moving up, I'm not moving down. It's just staying right where it's at. Any questions so far? All right, so let's go ahead and draw a table of values. for our graph. So this is why we need a starting point, because that's what's going to tell me where my table of values is going to start. So your starting point is always h comma k, where it's the opposite sign for h. So the opposite of -1 is +1, and then k, so 1 comma 0. For square root functions, your critical point will always be the first point in your table of values. So you're going to put it right at the top. So on Friday, we calculated it all by hand, but it's really hard to calculate it by hand if you've got an a value. So it works really well if you just have an h and k, but as soon as you introduce that a value, it makes it a little bit more complicated to choose x values. So I prefer using the graphing calculator. You can still choose x values and do it by hand if you don't have a graphing calculator. So you'd want to choose 3 numbers that are bigger than 1 to try to plug in. But I think it's actually easier to just use your graphing calculator. So I'm going to go ahead and go over that. If you need me to slow down, just stop me, because I can't see what you're doing with your calculator. So if you want me to go over a step again, just let me know. You're going to start by turning on your calculator, and then you're going to hit y equals. If you have something already in the y equals section, press clear to clear it out. And then you're going to type in your equation. So it's going to be negative. So you're going to type in the number under the 3. That's your negative sign. Do not put the minus right here. That's going to make your calculator angry. And then to get the square root, you're going to hit second, x squared. And some calculators will look like mine, and some calculators will have a parentheses. If your calculator, does anyone have a parentheses on their calculator? No, we're all good? Okay. So once you've got the square root, you're going to type in x. So x is right here under mode. And then -1. All right, you want to make sure the radical ends. So you want to get rid of that extended radical by just typing that right arrow, and that should get rid of your radical. And then we are going to go ahead and graph that. So to get this, so this is what your graph looks like. To get the table of values, you're going to hit second and then graph. And then it's going to give you a table of values. Remember I said that you want to start at 1, 0. So my graph, or my table of values right now is at 5. I don't want that. So I'm going to scroll up until I get to 1, 0. And then you want to choose points that are easy to graph. So you'll notice that a lot of these are decimals. Those are going to be kind of hard to graph. So I'm going to choose whole numbers that are easy to graph. So we got 1, 0. Then I'm going to go with 2, -1. And then I'm going to scroll down until I get 5, -2 will work. And then 10, -3. Any questions about that? All right, let's go ahead and graph this. So we've got 1, 0, 2, -1, 5, -2, and 10, -3. So you'll notice compared to my parent function, which I'm going to do in green, you don't have to do this on your paper, but just to show you, if I plot my original parent function point, you'll notice that I flipped it over and then I moved it to the right one. So that's how I got the new graph. All right, the domain and range as a review from Friday, the domain is always in the format x is greater than or equal to your h value, but the opposite of that, so the opposite of -1 is +1, so it's x is greater than or equal to 1. And then your range usually is y is greater than or equal to your k value, which is 0. But you'll notice that when we flipped it, all of my numbers are now below 0. So they're less than 0. So anytime you have a reflection, you also need to flip the inequality. So it's y is less than or equal to 0. Questions on that? All right, example 2, graph the following function, f of x equals negative cubed root of x plus 3. So first we're going to list out what type of graph it is. What type of graph do I have for this function? Liana.
A square root.
It's not a square root. What's the index?
A square.
It's actually a cubed root function because the index is 3. So this is going to be a cubed root function. Does that make sense, Liana?
Oh, I can't see it.
Oh, gotcha. There you go. I think it might be your internet connection. All right, next thing we have to do is find our A, our H, and our K. So our A, H, and K. What's going to be my A, what's going to be my H, and what's going to be my K? What do you think, Sandra?
Your A is -1.
Mm-hmm.
I guess your H. You don't have an H.
You don't have an H.
0.
Yep, 0.
And your K is 3.
Good job. All right, so Sandra said that A is -1, H is 0, K is 3. So how does that shift my graph? What do you think, Ethan?
It makes the graph reflect over the x-axis
Good, because the A.
and go left 3.
Well, remember your H is 0, so you're not moving left or right. So that 3 is the K. So how does the K move the graph?
Up 3.
Up 3, yep. Good. So then you have to figure out what your critical point is. So your critical point is always H comma K. So your H is 0, your K is 3, so it's 0, 3. And here's the difference between square root functions and cubed root functions. This is why it's important to specify what you have. For cubed root functions, your critical point is going to go right in the middle of your table of values. So for square root, it goes at the top, but for cubed root, it goes in the middle. So you're going to choose two numbers that are smaller than 0. So I would go with, well, you'll need your table or you'll need your graphing calculator for that. So two numbers that are smaller than 0, two numbers that are bigger than 0. So you're going to go to y equals to plug in your function. You're going to press clear to clear out the old function. And then you're going to type in the new function. So you've got the negative sign right here under the 3. And now you want to get the cubed root. So to get the cubed root on your calculator, you're going to have to hit math. Then you're going to hit option number 4 for cube. Then you're going to type in the x. And you want to end the radical right there. So you need to move the right arrow over to get rid of the radical because you don't want it to extend all the way to the +3. Questions on that? Now we're going to graph it. And then we're going to get a table of values. So you're going to hit second table to get your table of values. You want 0, 3 to be in the middle. So you're going to scroll until you get to 0. All right, so, oh, I scrolled too far. Okay. So you want two numbers that are smaller than 0 that are easy to graph. So I would do -1, 4. And let's do, gotta scroll for a little bit, -8, 5. And then you're gonna scroll down to get numbers that are bigger than 0. So I would go with 1, 2, and 8, 1. Any questions so far? All right, let's go and graph it. So we've got -8, 5, -1, 4, 0, 3, 1, 2, 8, 1. Any questions about how we graph that? All right, domain and range is always very easy for cubed root functions. It never changes. The domain is always all real numbers. And the range is also going to be all real numbers. Any questions about example 2? Does anyone need more time? All right, let's look at the last example, or last graphing example. Example 3, we've got 2 square root of x minus 1 minus 2. First question, what type of graph do I have, square root or cubed root? What do you think, Venus?
X square root.
Square root, good job. Next question, what's my A, what's my H, and what's my K? What's my A, H, and K? What do you have for me, Nancy?
Your A is going to be 2, and then your K is going to be 0.
Remember, your K is the number after or behind.
Yeah, then the -2.
And your H is?
And then H is -1. Yeah, -1.
Yeah, that's
Or is
fine.
it just? Okay.
I like to put the negative just to remind me that it's like how it's gonna move, but that's up to you. Not Ethan, sorry. How does this make my graph move? How does this make my graph move? What do you think, Sandra?
Is it x greater or equal than?
Oh, not the domain. Sandra, just how does this make my graph move? Is it gonna move up, down, left, right, stretch, shrink?
What do you? I don't know. I'm confused.
Well, what does the H value do? If it's H is -1, how does that move my graph?
Reflect over x-axis.
That's the A value, but the H value, what does that do?
Is it down or right?
Remember, H is horizontal, and since it's a -1, is it going to the right or is it going to the left?
Right.
Right 1, what does the K do?
Down 2.
Down 2. And then the A value, if it's positive, then it's not reflecting. But it's a 2, and 2 is bigger than 1, so it's going to be a vertical stretch. So it's a vertical stretch by 2, right 1, and then down 2. Any questions about that? All right, so now we're going to go ahead and fill out our table of values. Your table of values is the opposite of h, so +1 and then k, which is -2. Since this is a square root function, your table or your critical point goes at the very top, so 1, -2 goes at the top. And then you're going to choose 3 numbers that are bigger than 1 for your table of values. So for that, you're going to need your graphing calculator. So you're going to go back to your graphing calculator. You're going to turn it on. You're going to hit y equals. Clear whatever's in there already. Then you're going to type in the function. So it's 2. And then second function square root of x minus 1. Then you want to move to the right to get rid of the radical, and -2 should be outside of the radical. Then you're going to hit graph. And then you're going to hit second function graph to get your table of values. You want to scroll till you get 1, -2, because that's your starting point. And then you want to choose 3 other points that are easy to graph. So I'm going to go with 2, 0. And then let's do 5, 2. And then let's do 10, 4. So we're going to go and graph that. So 1, -2, 2, 0, 5, 2, and then 10, 4. So your domain is always x is greater than or equal to whatever your h value is, but change the sign. So it's x is greater than or equal to 1. And your y, or your range is y is greater than or equal to your k value, which is -2. You can keep it as greater than or equal to because it did not reflect. Questions on example 3? All right, the last one, example 4. Write a rule for g described by the transformation of the graph f, where f of x equals the cubed root of x. Let g be stretched by a factor of 2, shifted up 5, and right 3. So this time we're working backwards. We know what our transformation is, but we need to figure out what the equation is. So from the front page, the general equation is g of x is equal to the cubed root of x minus h plus k. So I need to figure out my A, my H, and my K. My A, my H, and my K. All right, so my A value, my H value, and my K value. Go ahead and fill those in for me based on this equation. What do you have for me, Ethan? Sorry, Ethan, I think you're still muted.
Your A is going to be 2. H is going to be -3. And then the K is going to be 5.
5. So when you plug that in, your A is 2. The cubed root of x minus 3, you want a minus because you're going to the right, and then plus 5 for your K. And that's your final answer. Any questions on that? Any questions? Any questions? Does anyone still need this before I switch the screen? Okay, a couple things I want to share with you before we leave. I just linked this really nice resource to our class homepage. For those of you that don't have a printer and have been struggling to write down your notes, my colleague, so another math teacher named Mrs. Denning, she made this really cool video to show you how you can use your Chromebook as a tablet to actually take down notes. So there should be a stylus on the back of your Chromebook, and you can use that and fold your Chromebook over so that it looks like a piece of paper, and then you can actually take your notes that way. So if you go to my homepage and then you click class resources, if you click this video for how to edit a PDF, it will take you to her link, and the video shows you how to edit the PDF. So all my notes are PDFs, so you can download the notes and then write directly on them. And then she also shows you how to do that while watching the Zoom. So you can have the Zoom on half the screen and then the PDF on the other half of the screen, and then you could take notes that way. So that may be a little bit easier for you than trying to copy it down on a blank piece of paper. And you can also do that for any Canvas assignment that I put up. So if I put up a worksheet, you can download the worksheet as a PDF and then just write it down, write your answers down on the PDF directly and upload that instead of having to take a picture. So that's a really good resource if you are interested. Highly recommend looking at that on your time if you have extra time today. Secondly, your homework for tonight is 5.3 part 2. That'll be due tomorrow at 11:59, and then you also have your 5.3 assignment that will be due tonight at 11:59. I'm going to stick around till the end of the period if you want to get started on your work with me. If not, I will see you tomorrow.